record this. Okay, which one in particular did you have? Number 4. That dealt with the, oh yeah. And the way they had to enter the answer in, which was it as a, how did you all enter your answers for that one? Okay. This, yeah, they weren't in fractions. Okay.
Yeah, can you just explain on my
Okay. In part A, where it says that what is 40% 0.25 M? All right, in this case here, that 40%, if I write that as a decimal, that would be 0.40. And the word of means you have to multiply. And then 0.25 M. Now in the answer, there we got the M there. All you have to do there is just do 0.40 times 0.025. Now you have to do this, just enter that answer there. So you do this is, in this case, 0.01, and the M is already there for you. Okay. So that right there represents part A.
So you just take off the rest of the numbers. I got it right on here, but I have different numbers first of all. But I got 0.0135, and that was right on here.
Okay. It depends upon what.
Okay.
Yeah.
No,
because see, these numbers that I have in red, these numbers change. Yeah. And in part B, you have what percent of 7.6 pounds is 30 pounds. That's A, this is B. In this case here, we're gonna say what percent, you can say P over 100, because P percent means that over 100. And the word means to multiply. 7.6 is the equal sign, and then 30. So in this case, if I write this as 7.6 times P over 100, that'll be equal to 30. And then in this case, multiply both sides by 100. So that means 7.6 P would be equal to 3,000. Then divide both sides by 7.6. This should give you the percent. So 3,000. Let's see. This is going to be hard right here because this is like, well, leave this as a fraction, but you can reduce this in simplest form. Well, I get that decimal in the denominator, so that means I need to multiply the numerator and the denominator by 10 to make it a whole number. Okay. This will give me 30,000 over 76. And to reduce 30,000 over 76, if you divide the numerator and the denominator by 4, I know 30,000 divided by 4 would be 7,500. And then 4 goes into 76 19 times. And that's exactly the answer that I got.
Why would they not just have you divide that into a decimal?
I have no idea. Because that's what I was thinking. Because here they want this as a fraction in simplest form. And they should give you better directions on how they want you to write that answer. Okay. All right, any questions about how that problem is done? Okay. And this last one right here, 39 feet is what percent of 242 feet? I apologize if this. Someone had this because I'm going to need to erase. I know part A. All right, so this is 39 feet is what percent of 242 feet? Feet is what percent of 242 feet? Okay, so I need to erase, let me erase this part right here. All right, so 39 feet, I'll just write this as 39. I'm just writing this as an equation. The word is will be equal sign. What percent of is to multiply, and then 242. So if I write this as 39 is equal to 242 p over 100. And then the next step would be to multiply both sides by 100. On this side, it'd be 3,900 is equal to 242 times p. And then divide both sides by 242. just say this. I'm gonna put the P on this side and the 3,900 over 242 on this side. And in this case here, if I divide the numerator and the denominator by 2, because they want this as a fraction in simplest form, 3,900 divided by 2 would be 1950. And then 242 divided by 2 would be 121. On the other one, I forgot to put this percent on, but in that problem, they do have the percent sign. You just have to type in the fraction. So it'd be 1950 over 121%. Okay. So I guess that's how they want that answer in simplest form. Okay. Any other questions about the homework you never signed? Okay. So that should help you answer those questions correctly according to them. Okay. We'll go question.
Oh, thank you.
Okay. All right. So now we can go ahead and start chapter 7. Okay. Now in chapter 7, we're going to be dealing with algebra and functions. So in this case, we're going to be representing creating functions in the first section. And then the next section will be dealing with things like solving equations. And the third section is going to be dealing with how to use something called algebra tiles to represent solving equations. So the first section is just representing and creating functions. Okay. So here we can, let me move this up. Okay, so here we can represent a function with numerical inputs and outputs, also using a table or a graph or an equation or just simply words. Okay. So that's how we can represent a function various ways. Okay. And these are just some of the things that students should be able to do here when you're dealing with functions here. A table records and organizes the data to help them explore a pattern, a graph to let them see the relationship between two variables, words help them describe the story, and an equation allows them to quantify a relationship and obtain ordered pairs that may be infeasible to obtain from a table or a graph. Okay. So here we'll talk about concepts and representations here. Okay, so here, a function is a predictable relationship between two variables. So in this case here, let's say we have a game that consists of spinning two spinners, spinner A and spinner B, as shown here. As you can see, spinner A has those numbers 2, 4, and 6. And spinner B has just 5, 6, and 7. And notice how these are sectioned off differently. Here, spinner A is sectioned off in thirds evenly, but in spinner B, it's a little bit different here. It has those pieces sectioned. If the number from spinner A divides the number from spinner B, then you win a prize. Okay. ignore this part right here. All right, this problem requires thinking about two variables at the same time. So here, these are the winning possibilities. Oops. Those are the winning possibilities. Spinner A points to 2 and B points to 6. A points to 2 and B points to 8, and so on. So here, this would be an example where ordered pairs can be used to represent relationships. So the ordered pair is a pair of elements X and Y that are written in this form, X comma Y, in parentheses. So here, X and Y are what we call coordinates. And those are used when we're usually plotting points on a coordinate plane. So X and Y are called coordinates. So here we say that the X is the first coordinate and the Y is called the second coordinate. And of course, in algebra, we usually call the first number the X coordinate and the second number the Y coordinate. Okay. So here, if we were dealing with that particular example, we would look at spinner A as the number from the first, as the first coordinate, and for spinner B, those numbers would represent the second coordinate. So here, this right here represents a list of winning outcomes in that set. Okay. So if I let A represent the set 2, 4, and 6, and B represent the set 5, 6, 7, and 8, here they're going to use the Cartesian product. Now, somewhere back in probably Math for Teachers 1 or 2, or pretty much wherever, I know in 1, we talk about the Cartesian product of two sets, A and B. And that's going to be the set of all possible outcomes from spinning both spinners. So if I do A cross B, this would be the set of all the possible outcomes from sets A and set B. Okay, and the set of winning outcomes would be these 4 ordered pairs. Okay. And we call that a relation. Now, relation from set A to set B is the subset of the Cartesian product A and B. Okay. Now, any relation from A to itself is called a relation on A, and a relation does not have to be meaningful. So any subset of A cross B is a relation. And what they mean by A being a relation, any relation from A to itself. So this is A, which is in this case, it's just going to end up being like this. 2 to itself will be 2 comma 2, and then 2 to 4, 2 to 6. And then we do 4 to 2, 4 to itself, and 4, 6. And then 6 to 2, 6 to 4, 6 to 6. That could be a relation from A to itself. All right, now it is helpful to think that a relation, some type of relationship between two sets of varying quantities. Okay, now we can think of relation in terms of ordered pairs like we have here, and also we can use rules or words to describe some relations and then represent the relationship as a set of ordered pairs. Okay. So in this example, let's say we let A be the set 3, 4, and 6, and B be the set 3, 6, 7. And we want W to be the relation from A to B consisting of ordered pairs X and Y such that X plus Y is an even number. And let's say I want to represent W as a set of ordered pairs. Okay. So W is going to be some relation from A to B such that the sum of those X and Y coordinates would be equal to some even number. Yeah. So these are the possible sums. If we look at 3 plus 3, that would give us 6. And 3 plus 6, that would give us 9. And 3 plus 7, that would give us 10. And then next would be 4 plus 3, that's 7. 4 plus 6, that's 10. And 4 plus 7, that's 11. And then compare the 6 with each one of those numbers in B. 6 plus 3 is 9. 6 plus 6 is 12. And 6 plus 7 would be 13. So those are the possible sums when we do the cross product of A and B. Because if I look at this and I write this as a set of ordered pairs, this would be 3, 3. The other one would be 3, 6. And 3, 7. And then next 4 will be paired with each element, each number in B. So it'd be 4, 3, 4, 6, 4, 7. And then next 6 will be paired with each element. So it'd be 6, 3, 6, 6. And 6, 7. And then you take the sum of the X and the Y. So 3 plus 3, that's 6. 3 plus 6 is 9. 3 plus 7 is 10. And I'm just going to go ahead and fill in the rest. Okay. So all I'm doing there is just adding up the X and the Y to get each of these numbers. And it has to be such that X plus Y is an even number. So you can see here, this is an even number. There's another even number. There's another even number. And here's another even number. And of course, even numbers in this case are 2, 4, 6, 8, 10, 12, and so on. So here the sums 6, 10, and 12 are even numbers. So that means W will be this set. If I have 6 here, that means that the ordered pair 3, 3 fits that. That sum is 10, so the ordered pair there would be 3, 7. Another 10, that's 4 and 6. And at 12, that's 6 and 6. This represents the relation for W from A to B, which consists of ordered pairs such that the sum of the X and Y coordinate is an even number. And this is the final answer right there. Okay. All right, any questions on example 1? Okay. All right, now the ordered pair XY has 2 coordinates. Okay, so here we can think of the first coordinate, which is your X, as the input or the independent variable. Because basically the independent variable can be anything that we want. And the second coordinate, which is your Y, that's going to be the output or the dependent variable. Usually that would mean that the Y would depend upon what X is. Okay, so that's why we call it the dependent variable. Okay. And it is helpful to think that of the independent variable as the quantity that we want to specify and the dependent variable as the quantity we want to measure or calculate. Okay, so there is a relationship between the set of inputs and outputs. Okay, now, next we'll look at functions as a special relation. Okay, so here's the definition of what a function is. And domain, range, and codomain. A function is a relationship from set A to set B such that each element of A, that's the inputs or the independent variable, corresponds to exactly one element of B. So in order to have a function, you can only have one X value going to only one Y value. You cannot have an X value paired with two or more different Y values. If that's the case, then you would not have a function. And by looking at this one right here, where we got the relation W from the cross product of A and B, if you were to look at this particular relation, it would not be a function. And here's why. Because you have to look at your X coordinates only to determine whether or not you have a function. In this case, 3 is paired with 3, and this 3 is also paired with another number, 7. So this would not represent a function. You have to have exactly one X value to only one Y value.
Why?
Why this is not a function?
No, why is that not
That's,
a function?
well, this
I
wouldn't
mean, it
be.
creates a straight line.
Here's why. And I'm glad you asked, because if I did something called a mapping of W with my X coordinates, let's say this is X and this is Y, and I'll list all the X coordinates here. Here's 3. And 3 I've already got, so I'm not going to list it again. Here's 4, and that's 6. And these are my Y coordinates here, 3, 7, and 6. So here, for this ordered pair, 3 is paired with 3. So that 3 goes here. 3 also goes to 7. That's the reason why it's not a function, because you got an X value going to 2 different Y values here. That's why it's not a function. And I'll go ahead and finish the rest of this. 4 goes to 6 and 6 goes to 6. All right. Okay. It's just a rule and the definition of what a function is. So by looking at this, if your x values repeat, then you will not have a function. You can also think of that. All right, any other questions?
Y's can repeat, isn't that right, Carmen? That you can have the same Y, but you can't have the same.
Right.
Okay.
You can have the same y going to two different x values. That's okay. But you can't have the same x going to two or more different y values. Right. Think of the vertical line test. Probably remember that from college algebra, I hope. Because if you take that vertical line, that figures. If you take that vertical line, through that graph more than once, it's not going to be a function. Okay. Any other questions? Okay. Now to set up the first coordinates or the inputs, that's your domain. So in this case right here, since I got this up here, these x coordinates right here represent the domain. And the second coordinates are the outputs, that's these numbers right here. We call that the range. Okay. And in this case here, set B, they call that the codomain of the function, meaning that the range is the subset of B.
Why wouldn't it just be B?
Oh, it is. Now, I didn't give an example of what a codomain would be. But that is, this right here, the whole thing is the domain. Now, well, I don't think that codomain you will have to worry about. Just think of the domain and the range. Okay, because I think that's something that's used in calculus. Okay. All right, in this example, here we want to use set notation to represent the domain and range of the function table that's shown here. Here we got our inputs on the top row and the outputs on the bottom row. So here the domain is just a set of all your inputs, so all x values, if you want to think of this that way. And that's of course 1, 2, -3, and 4. Whereas the outputs, notice that 3 is listed twice, but we list that only once. And the same holds true for the domain. If each input is listed more than once, you just list it only one time. You don't repeat.
What's
So
the weirdness with the order?
doesn't matter. I don't think the order matters here. Okay. Any other questions? Okay. I'm just skipping over that slide. All right. In this example, they want you to determine whether the relation Q, which is the ordered pair of 1, 0, -2, 0, and 3, 1, and 4, -1, -2, 3, is a function from A, which is 1, -2, 3, 4, to B, which is 0, 1, -1, 2, 3, and 4. And here they want you to use a arrow diagram and use a rectangular coordinate graph. So these are just a couple of representations of determining whether or not you have a relation being a function from A to B. Now here's the arrow diagram that they were talking about here, which is similar to the one that I just did here. Okay. Now, as you can see, in this case, that 1 is paired with 0. -2 is going to 0. 3, which is here, that goes to 1. And then -4, well, for -1, that 4 is going to -1. Also, -2 is going to 3. So by looking at this, would this represent a function? No, it wouldn't. And why would that not be a function? -2 goes to 0, and -2 is also going to 3. So you've got an x value, an x coordinate paired with 2 different y coordinates. So this would not represent a function. So here the left side lists the domain, the right side of the diagram lists the codomain or the range. Okay. And this indicates that it's not a function. Now, part B is the graph. If you look at this, if I did a vertical line test right here on this particular number, -2, you see that -2 has 2 different y values. -2 is with 0, and -2 is also with 3. So from that, you can see that this particular situation would not be a function. Okay. All right, questions on this example? Okay. All right, next we'll talk about function notation. Okay. Let's say we had this situation where Mary has 5 fewer than 3 times as many coins as Tim. So if you know how many coins Tim has, then you can predict how many coins Mary has. And here we can use such an equation like this. M, being Mary, equals to 3T, that's the number of coins Tim has, minus 5. 3 times as many coins as Tim, and 5 fewer than that would be 3T minus 5. That's how you would write that as an algebraic representation of the function. And here's another way you can write it. M of T, where you got M with the T in the parentheses. M of T equaling to 3T minus 5. Okay, so this is the definition of function notation. And in this situation, it gives you 3 different significant messages. The variable M depends upon the variable T. So each ordered pair has the form T comma M. So here your T is going to be the independent variable, while M is going to be your dependent variable. Okay. And the equation M of T is equal to 3T minus 5 that describes the function and tells how the input of T is related to exactly 1 output of M. And it would be a function because for every value of T that you assign to it, you're only going to get 1 value for M, only 1. Okay. So here's the definition of function notation. And we read that as f of x and not f times x. This is f of x.
So is that as far as you can go on the equation? On the answer for the
Yeah.
question?
Mhm.
Because you don't have either 10.
You don't-
or-
You don't know what t is.
You don't have his number of points or.
Yes, yeah.
Because you don't have his, you can't get it.
Mhm.
Okay.
Any other questions? Okay. So here f of x is how we read that. And also y is equal to f of x. Or we can read that as y as is a function of x. And by the way, y and f of x do mean the same thing. It's just another way of writing y as f of x. Okay. So that notation y equal f of x means that the variable y is a function of the variable of x. X is the independent variable and y is the dependent variable. Because usually y depends upon what the value of x is. Okay. So in this case here, a male cricket chirps to attract female crickets. The warmer the air temperature, the more frequently the cricket chirps. You can estimate the air temperature in degrees Fahrenheit by counting the number of chirps it makes in 15 seconds and adding 40. So that's an example of a situation where we want to convert that into a function. So in part A, you're to express the temperature as a function of the number of chirps in 15 seconds, and then estimate the air temperature when the cricket chirps 24 times in 15 seconds. And how many times will the cricket chirp in 1 minute when the temperature is 72 degrees Fahrenheit? And at what temperature will the cricket stop chirping? Let's start with part A. N is going to be the number of times the cricket chirps in 15 seconds. And then we're going to let T sub n, or you can say T in this case for the temperature, in degrees Fahrenheit, when the cricket chirps n times in 15 seconds. So this would be the function. T sub n equals to n plus 40. That's the number of chirps plus 40. That would be T sub n. Now here they give a restriction. And I don't know why they say 0 is less than or equal to n. I would say n is greater than or equal to 0. Okay. And they probably said that because a cricket can't chirp negative number of times. So it's got to be either 0 or more. Now for the B part. 24 chirps. Okay. So here we're trying to estimate the temperature when the cricket chirps 24 times in 15 seconds. So your n is going to be 24. And then we just substitute 24. I mean, in place of n, we substitute with 24. So it'll be 24 plus 40 or 64. So the temperature is about 64 degrees Fahrenheit. And then part C, when the temperature is 72 degrees Fahrenheit. And here we have an equation. T sub n is the temperature, that's 72. That's going to be equal to n plus 40. Because here in part C, we want to find out how many times the cricket will chirp in 1 minute when the temperature is 72 degrees Fahrenheit. So this is the equation. 72 is equal to n plus 40. And on the next slide, if you were to subtract 40 on both sides, now go ahead and show that on the whiteboard. So if you subtract 40 on both sides of that equation, you'll get n is equal to 32. Now that n is equal to 32 represents the number of chirps the cricket will do in 15 seconds. But the problem asks for in 1 minute. And a 4, in this case, comes from this. We got 15 seconds. 1 minute consists of 60 seconds. So if you do 60 divided by 15, that would give you 4. So we take 32, multiply that by 4 to get 128. So in 1 minute, the cricket will chirp 128 times. Okay. So keep in mind that 1 minute represents 60 seconds. So 32 chirps in 15 seconds. If I divide 15 into 60, that would be 4. And then 4 times 32 will be 128. All right, questions on part C. Now, at what temperature will the cricket stop chirping? Well, n is equal to 0 means that the cricket has stopped chirping. So all you do there is take that formula in part A and just substitute your n with 0. And that will tell you the temperature. So the 0 plus 40 equals 40. That means that the cricket will stop chirping when the temperature is 40 degrees Fahrenheit. All right, any questions about example 11 and how that problem was done? Okay. All right, here's a problem out of the textbook on page 378. A taxi company charges $1.60 for the first fifth of a mile and then 30 cents for each successive fifth or part of a mile. And I want to let M represent the number of miles to complete the trip. And in part A, they ask for what is the cab fare for a 1 mile ride? Okay. $2.80. All right, let's come up with a formula for this. Okay. Yeah, because in this case, here's $1.60 for the first fifth mile, and then 30 cents for each successive fifth mile. And you might want to do this. Sometimes drawing a figure may help. So this represents 1 mile here. So that first fifth of a mile, and I section this up into 5, that's $1.60. And then 30 cents for every successive fifth part of the mile. So that's 30 cents here. The next fifth of the mile is 30 cents. The next fifth would be 30 cents. And the next fifth would be 30 cents. So for a 1 mile ride, if I add $1.60 to 30 cents each time, this will end up being $2.80. So that would be the cab fare for a 1 mile ride. All right, questions on part A. Now part B, the cab fare for a 2 mile ride. How much? Okay, well, not quite, because notice the first is $1.60. So right. Because that's the first mile, and then for 2 miles, a section off in fifth, so $1.60 for the first fifth of a mile, and then 30 cents afterwards.
So they don't recharge, because it says first fifth of a mile and for each successive part.
Yeah.
I did it too.
Okay. That's the first fifth of a mile, and then 30 cents afterwards. So I know that first mile was a total of $2.80. Okay. And these add up to $1.50. And this will end up being $4.30. So $4.30 would be the cab fare for a 2 mile ride. Questions on part B? Okay, now here comes part C, where it says here express the cab fare, which is going to be C, as a function of M. So that's B. So it's going to be C is equal to something. Okay. So we know the first fifth of a mile is $1.60. Plus, now, we got each mile section off into how many parts?
5.
Actually 5. So I know it's going to be 5 times. And we're letting M represent the number of miles. So this will be M. But notice that that first fifth of a mile is $1.60. And the rest is 30 cents each. So it has to be -1. Because that first fifth of a mile is $1.60. And that's covering that part.
Where's 0.3?
You know what? I messed that up. Yeah, I messed that up. This is wrong. Because 30 cents for each additional mile has to be 0.30. And that's going to be multiplied by if it's section off in 5s, it means 5M. minus 1. Because each mile is sectioned off into fifths. The minus 1 comes from the fact that the first fifth of a mile is $1.60. That would be the formula. All right, any questions about part C, how that was derived? None? Okay, so now we're going to use this formula or that function in part D to calculate the cab fare for a 7.4 mile ride. So C of 7.4 and M is going to be 7.4. So here we take that function in part C and just substitute your M with 7.4. And what I'm going to do here is let's see, 5 times 7.4. That'd be 37. 37 minus 1 would be 36. And then 36 times 0.30 would be 11.1 or $11.10. And if we add that to the $1.60, should get $12.70. Okay.
I have a different number.
I do too.
Oh,
0.3 times 30 should be 10.8.
okay. 130 times 36, I multiplied it wrong, 10.8. So it'd be $10.80. So this will end up being $12.40. Okay. So that's how we do part D. Questions on that? Okay, now I'm gonna need to erase this because part E asks for the number of miles for the tax ride. So this means that this C is going to represent $26.80. And that's going to be equal to $1.60 plus 0.30 times the quantity 5M minus 1. All right, so what I'm going to do here is remove the parentheses on the right side and combine like terms here. So this will be $26.80 equaling to $1.60 plus, and then if I distribute 0.30 times 5 or 0.3 times 5 will be 1.5 M minus 0.3 times 1 would be 0.3. And if I combine like terms, $1.60 minus 30 cents, this will equal to $1.30 plus 1.5 M. And And then to get the 1.5 m by itself, we need to subtract 1.30 on both sides. So on this side is 1.5 m, and on this side, this will be 25.50. So I have the equation 1.5 m is equal to 25.50, and then divide both sides by 1.5. How much would that be, 17?
Yes, sir.
Okay. So the number of miles for that taxi ride was 17 miles. If the fare was $26.80. Okay. All right, any question about problem number 7? Now this is problem number 14 in your textbook. In some cases, when oil spills in the ocean, the area of the oil that spreads on the surface of the water can be approximated by the area of the circle, which is in this case, A is equal to pi times the radius squared, where R is the radius due to its circular shape. So here's part A. What is the area of the oil slick when the radius is 11 meters? And here they want you to round your answer to the nearest square meter. And keep in mind, area is always going to be in some square units. And here we're using this formula, A is equal to pi r squared. And the radius in this case is 11 meters. Okay, so substituting the R with the 11. I now want to tell you what, this pi, we're going to say A is 3.14. That's the approximate value of pi. I don't know why they don't tell you to use 3.14 for pi, but we're going to use that here. Okay, so if I do 11 squared, which is 11 times 11, that'd be 121 times 3.14. You'll get 379.94, but let's say we're told to round to the nearest square meter. What would that be? To the nearest whole number? 380. And it would be 380 square meters. Okay. Questions on part A? Okay. All right. Part B, suppose the area of the oil slick was 152 square meters. And we want to approximate the radius of the circular oil slick to the nearest meter. So we know the area is 152 square meters. And we're using that formula, A is equal to pi times the radius squared. So that A is 152. And I'm going to let pi be 3.14 times the radius squared. So now to get r squared by itself, I need to divide both sides by 3.14. I'm gonna do this, 48.4076. Now to find out what R is, we're squaring it. So the opposite of square, you have to take the square root of this number.
Can I ask something?
Yes,
When you plugged the area in, wasn't it already squared? So when you have to square root both sides?
we do that at the end. Okay, yeah. Because you want to get R squared by itself first, and then take the square root. Now, this is what I come up with. But to the nearest meter, to the nearest whole number, this will be 7. So it'll be 7 meters for the radius of that circle. Okay. All right, any questions about problem number 14? I think this one is similar to the homework in section 7.1. Okay. All right, I guess we'll have to wrap it up right here for this particular, for now. Okay, I will finish the rest of this on Wednesday for section 7.1. We'll be dealing with things like how to do various representations of a function, talk about algebra functions, adding, subtracting, multiplying, and dividing two functions, f and g. And then we'll go into section 7.2, dealing with solving equations. Okay. All right, make sure that your signature is on that sign-in sheet so that you'll be counted present. And I will see you on Wednesday.